These two shots of what is sometimes a predator-prey interaction and sometimes the beginning of a parasite-host relationship are some of the most scientifically interesting clips I've ever captured. What you're looking at is a solitary wasp with incredibly specialized vice-gripping claws going after plant hopper nymphs. The plant hoppers with their spring-loaded jumps, as you'll see, aren't the easiest things to grab a hold of. And this footage is part of a new study I contributed to describing how these incredible wasps work. To get those shots, I spent a day in the biocontrol lab at the University of Rhode Island. Those two sequences you saw at the beginning were the main products of 6 hours of filming with two collaborators helping me wrangle the insects in front of the camera. The reason why I filmed them in a biocontrol lab is they specialize on parasitizing plant-feeding insects like this plant hopper nymph that you're seeing now. Plant hoppers and leaf hoppers can be crop pests, so the lab I was filming in was studying these wasps as potential biocontrol tools. Now in these shots, you're actually seeing both the hopper nymph and the wasp. That brown bulge sticking out the side of the hopper is the developing larval wasp. The body of the larva is positioned in that structure, which is made up of larval molts that have hardened into a protective shell called the thylacium. The head of the larval wasp is inside the hopper and feeding, even while its host is still alive, moving, and feeding itself. Now these wasps belong to a family of insects commonly known as pincer wasps in the taxonomic family Dryinidae. Dryinids can be found worldwide, and there are just under 2,000 described species. Some of them are winged, some are wingless, but all of them are solitary parasitoids, depositing their eggs into hoppers and feeding on them all the way through larval development. The adults can be variable in size, but here's a larger species next to the tip of a pencil for scale. Now what I was interested in filming was how these wasps capture their host prey. Plant hoppers, along with all the other hoppers that these wasps target, have spring-loaded hind legs that produce some of the fastest escape jumps ever recorded. The wasps need to catch these insects pretty frequently too, because they don't just use them as a host, they also feed on them as prey, like you're seeing this one do. So, one of the main challenges with trying to film this was getting a wasp that perceived the particular hopper nymph as either prey or a potential host. Sometimes we could get the wasp and the hopper in front of the camera, but the wasp didn't seem to care and would even walk right over what we thought they would see as prey. The hoppers, however, still did care and were quick to escape from that situation. So the secret weapon these wasps have is this, extremely modified front legs that end in a foldable spring-trapping claw. This one's showing you the claw as it unfolds it to clean it. One of the things our new study does is describe how the anatomy of this claw works. In doing that, my collaborators made models like this from micro-CT scans of the front legs and claws. Now the part that you saw open and unfold is this part at the end. When they strike, this snaps shut on the target when it makes contact. What blew my mind about the anatomy of this claw is that this sharper half here is a modified version of one of the paired tarsal claws that all insects have. This thing down here is the other smaller half of that standard tarsal claw. To give you an idea of what a normal set of tarsal claws looks like, here's the leg of a roach ending with the claws. Even looking back at the pincer wasps, if you move back to the middle and hind legs, you can see that they end in a more normal looking arrangement with small tarsal claws at the end. On the front leg's trap claw, the other part here that snaps shut onto the target prey is a modification of the fifth tarsal segment. All of this is held folded back up on the leg, and this part, the aurolium, which is normally an adhesive pad on the tarsal claws of other insects, is used by the wasps as a foot when they move around. In these slow motion shots of running, look at the front legs and you can see the trap claw folded up and each step taken with that aurolium pad interacting with the ground instead of the claw. Okay, now that you've got a good idea of what these wasps are and what they're doing, let's look again at those two slow motion clips I captured of their attacks. You might have noticed that all these wasps have huge eyes. Well, the first step is visual recognition of a target and orienting the body to be in striking distance. Next, the front legs go up, but still with the claws folded away. This one spends a bit of time inspecting the hopper from this position before deciding that it's worth getting the claws out and going for an attack. Next, the legs are raised up and the claws are unfolded into attack position. At this point, we're pretty sure that they're setting them into place and loading an internal spring that will make the claws snap shut once they make contact with the body of the hopper. When it starts raising its abdomen to point upwards, a strike is about to happen. It throws the open claws at the body of the hopper and they clamp down. Of course, all this was filmed in slow motion at 6,000 frames per second, and it only took 3.7 milliseconds from when the claws started moving towards the hopper to when they clamped down on it. From here, the wasp injects paralyzing venom into the hopper and either decides to feed on it or use it as a host and inject its eggs into it. The second shot I was able to capture is from a different perspective, focusing on the hopper so that we can see what the claws do when they hit the target. Once the strike starts, I'll slow it down to go frame by frame so we can see how the claws stay open until they hit and clamp into the hopper. This one immediately responds with an escape jump that rips one of those claws loose, but the other claw stays attached and the hopper yanks the wasp into the air with it as it goes. I'll wind it back and play it again at one fluid speed so you can see that spectacular sequence of predator-prey behaviors happen all together. So most of what you just watched is part of a research project describing the functional anatomy and strike behavior of those wasps. If you want to read our scientific paper, I'll put a link to it in the video description below. That's it for now. Thanks for watching.